Good afternoon, sir. Good afternoon, sir. Sir, am I audible? Sir, good afternoon. Am I audible? With your permission, shall we start, sir?
Hello, good afternoon.
Good afternoon, sir. With your permission, shall we start, sir?
Oh, I don't know. What is the time? It's 2 o'clock.
Sir, it was, it was 2 o'clock. So they were coming back from their lunch. So we have little bit of delay in the case of students joining. So,
yeah, please go ahead as per your schedule.
Yes, sir. So with your permission, then we are starting, sir. Thank you.
Okay.
Thank you, sir.
Good afternoon, everyone. On behalf of Amity University, Rajasthan, and the organizing committee of the Conference on Sustainable Development and Applied Science, Engineering and Technology, ICGETEI 2025, I extend a very warm welcome to all our distinguished guests, keynote speakers, session chairs, co-chairs, faculty members, participants, and students. It gives us immense pleasure to begin this conference, which is a platform to share ideas, innovations, and research for building a sustainable future. So, we are honored to have with us Professor Kamalkant Dwivedi, Senior Vice President, RBEF, Amity University, Noida, Professor Nilima Kumari, Professor, Department of Bioscience and Biotechnology, Banasthali Vidyapeeth, Rajasthan, Dr. Nameer Khairullah Mohammed, Director, Scientific Affairs Department, Tikrit University, Iraq. So, now I would like to invite Dr. Geeta Sanket Joshi ma'am, Associate Professor AIMT, Amity University, Rajasthan, for the welcome address. So, please welcome ma'am with a huge round of applause.
Hello. Good afternoon and welcome. With immense pleasure and the blessings and support of our Chief Patrons, Honorable Founder, President Dr. Ashok K. Chauhan, and Honorable Chancellor Dr. Aseem K. Chauhan, I, Dr. Geeta, on behalf of Amity University, Rajasthan, stand before you today to welcome each and every one of you to the International Convention on Green Environment Technology and Entrepreneurship through Innovation, ICGETEI 2025, an international conference workshop on sustainable development in applied sciences, engineering, and technology, SDA-SET 2025, which focuses on the advancing sustainability in the field of science, engineering, and technology. I would like to extend a special welcome to all our keynote speakers, Professor Kamalkant Dwivedi, Senior Vice President, RBEF, Amity University, Noida, Professor Nilima Kumari, Department of Bioscience and Biotechnology, Banasthali Vidyapeeth, Rajasthan, and Professor Dr. Nameer Khairullah Mohammed, Director, Scientific Affairs Department, Tikrit University, Iraq. Your expertise and insights are highly valued, sir, madam. Your diverse perspectives and experience are invaluable to the success of this conference. I would like to now welcome all the esteemed professionals, faculty members, and research scholars, PhD scholars. We are excited to have such a delighted gathering of scholars, researchers, professionals, and enthusiasts from all corners of the globe. Your presence here today signifies the importance of collaboration and knowledge exchange in the field of science and technology. We are particularly excited to delve into the multifaceted aspects of sustainability in the fields of science over the next few days. This conference aims to provide a platform for insightful discussions, innovative ideas, and establishing new connections that will undoubtedly contribute to the advancements in the field of sustainable science and biotechnology. Let me take the privilege to welcome and introduce our first keynote speaker, Professor Dr. Kamalkant Dwivedi. Professor Dr. Kamalkant Dwivedi is presently the Senior Vice President of Ritanand Balved Education Foundation, Amity Group of Universities, and the president of Global Academy of Doctorates. He is a scientist, researcher, teacher, educator, administrator, diplomat, and a science communicator. For over 50 years, he served in India and abroad in different capacities as the Vice Chancellor, Arunachal University, Itanagar, Vice Chancellor of APJ Satya University, Gurgaon, and Vice Chancellor, ITM University, Gwalior. He is also served as Head of Division Advisor, NCSTS DST, and Director in the Ministry of Science and Technology, Government of India, as a Counselor in Science, Technology, Health and Education, Embassy of India, Washington, D.C. Visiting Scientist, University of Gießen, University of Marburg, and Hans Meissner Institute, Berlin, Germany, and faculty member in Northeastern Hill University, Shillong. He obtained his PhD in 1977 from IIT Kanpur and has specialized in the fields of chemical, nuclear, and environmental science, Science and Technology Corporation, Science Administration and Communication. From Dwivedi, Professor Dwivedi ji held a prestigious position of the President of International Nuclear Track Society representing more than 40 countries. He is founder president of the Global Academy of Doctorates and its network having about 6,000 members from 55 countries. He represented India as the head of the Indian delegation for SAARC SNT Committee Summit in Islamabad in 2009, serving as a member of the advisory board of the Department of Education in Science and Mathematics NCERT since 2018. Member of the advisory think tank of the World Forum for Education and BEST Innovation University since 2019, and also as a member of board and advisor Smart University Foundation USA 2019. He is recipient of the prestigious India 2000 Millennium Award 1999 and Saraswati Centenary Award Science Glory Award 2017 and was elected as a fellow of the International Academy of Physics Science FIAPS in 2011 and president of the Chemical Science for the centenary year 2012 to 13 of the Indian Science Congress. I once again welcome you, sir. Over to you, sir.
Good afternoon, everyone. See, the time that the host has taken to introduce me, there are about 30 football fields equivalent of forest has been already cut. They are already, there is a deforestation. So that is the speed by which, we are losing our forest. Anyway, actually today's topic is very interesting and very close to me. But before I say anything about what I wanted to say, I must, at the very outset, I must express my gratitude and thanks to the organizer, and especially Professor Manju Kaushik, because I have seen her arranging these conferences from last 5 years or even before. And she's a great integrator. She actually bundles all the ideas into one topic and try to make it so in-depth, activity like this one, which is called the 5th International Convention on Green Environment, Technology, Entrepreneurship through Innovation 2025. You see, nothing is left out. Everything is included. So that is the beauty of this. So I'm very happy to participate in this. Thank you. I welcome all of you, all the dignitaries, esteemed colleagues, distinguished guests, aspiring change makers like you, which are the future, and my dear students and faculty members. In fact, the topic on which that I'm going to speak today is called Engineering Tomorrow, Planning for Tomorrow in a very sustainable way, the Green Innovation for Sustainable Future. This is the title. So let us begin with a simple question. Shall I share my PPT?
Yes, sir. Yes, sir, please. Yes, sir,
Okay,
please.
okay. Okay, let me see where my PPT is. Uh, how to take it? I have to go to, is it visible?
Yes, sir. Yes, sir. It is visible. Yes, sir. It is in full screen now.
Wait a minute. Why these strips are coming? Okay, now it is readable.
Yes, sir. It is. It is. On.
So the first question that came to our mind is what kind of tomorrow we are engineering today. That means that if we are thinking about the sustainable development and we have to protect our climate, our earth, Mother Earth, then what kind of engineering is required to initiate it and execute it today? So as we all know that climate crisis and global resource pressures are there. So need for a sustainable growth model has to be adopted, and role of engineers as a future maker, or what we call as a change agent, in order to ensure that tomorrow is better than today. Friends, you know that everything is connected with every other things. That means that there is so much of interconnectivity in this nature. And because of the human activity and some beyond expectation, their need and their aspirations, we overexploit the nature for our good, but without even thinking about what kind of damage is there for the environment. You all know that today's population of the world is 8.24 billion. And if the same condition, and today actually every person has about 3.1 acre of land, which is habitable land. We exclude rivers and forests and snow-laden peaks, glaciers, and where human can live. Today, per capita land which is available on Earth is about 3.1 acre per person. But if the same rate of growth that is today goes on, that by the year 2100, we will be about 10 billion people. But let us not stop here. Let's think about now in the year 2600, now 575 years after today, what will be the situation? If the same population growth continues for the next 500 years, by the time that we reach 2600, we'll be having about not less than 850 billion people on the earth. 800 billion people on the earth means that we'll not have any place to lie down. All of us will be standing shoulder to shoulder wherever we can live on the land. So this is the situation that we are going to face if we don't really plan for today for tomorrow. So, and this planning is not really, can be done in years or in months or in decades. The climate change is a problem of now. The environmental degradation and rising population, as I told just now, is the main source of the pressure and the problem and challenge that is offering. Engineering must lead transformation. So as an engineer, as a scientist, we must plan for tomorrow in a very responsible way. Now, if we go to the next slide, that you know that what is green innovation. But before that, I would like to talk about some challenges that we are going to face or we are facing. Rising global temperature that we call as the greenhouse effects is already actually already posing a lot of problem. Water scarcity, especially the potable and drinking water, pollution of our air, soil, and seas, and the water bodies are very, very challenging that we have to protect. There are movement of people from rural to urban area for job and other reasons, and a growing demand of energy and other resources. They are because of the expanding population. So friends, if we have to concern about future, we have to actually start solving today's problem, the problem of now, but they also present today's opportunity. Now, these problems can also, they are also actually pose a lot of opportunity before us. So where some see a crisis, we must see a call for innovate. If we run into some policy, if we run into some kind of a crisis, we must think about some innovation. So that is how the innovation ecosystem has to be created. So what is green innovation? Let us simply, in a very simple term, let us define this. Environmentally responsible technologies are all coming under green innovation. Efficient, circular, and green systems and integration across sectors. As I told in the beginning that everything is connected to everything else. So the integration is a great process. And thereby, I think anything green that you think about has to integrate various actions and aspirations. Green innovation and technology systems and approaches that reduce environmental harm and optimize the use of natural resources. They encompasses renewable energy technology, solar, wind, hydro, and bioenergy. Smart grids and energy efficient infrastructure is needed for that. Sustainable materials and circular manufacturing are important. Green chemistry and biodegradable material need to be invented. Clean transportation system like electric vehicles and green hydrogen. Waste to energy system and water purification technology are needed, not only for clean environment, but also for good health. So what unites them all is their commitment to efficiency, minimalization, and ecological responsibility. So friends, I think the topic that we are discussing is extremely important, but it is multifaceted and a lot of dimensions added to it. Key areas of green engineering, I think these things are quite widely known to you. Renewable energy, solar, wind, hydro that I mentioned in the previous slide. Sustainable constructions and materials. We must not use some material which is ultimately causing pollution, or any disposable item should be biodegradable. Use of plastic has become last 30-40 years has become a problem of its disposal, because the plastic is not very easy to degrade unless we have a special plastic which is biodegradable. Clean transportation means all those noxious gases like oxides of carbon, nitrogen, and sulfur should be avoided from the atmosphere. And also the clean transportation means the use of lead, tetraethyl lead in the benzene or in the petrol should be completely avoided. Hydrocarbons should be absolutely avoided. So that is why I think the hybrid cars or electric cars are needed for clean environment. So clean transportation means electric vehicles, most of it. And we are happy that even in our country, where I think the population growth, even though under little control, but we are growing at about 1+%, that means that that in coming days, I think our population growth India's population will be the largest in the world. The smart grid and energy efficiency is important because, as you know, that producing energy causes a lot of environmental degradation. So I think we must have energy distribution system which is efficient, and smart grids are required so that the minimum power loss in transportation and in transmission should be ensured. I would like to share with you some success stories from around the world. And here I give some example. One from the Netherlands, that is the Holland. The engineers have designed floating farms and solar roadways, solutions combining food energy and climate resilience. So this is about the Netherlands. In India, this Pavagada Solar Park, the expansion of the solar parks, such as the Pavagata Solar Park in Karnataka, has turned arid land into a hub of clean energy. You see, a lot of wind turbines are there in this area, in this region, and that is why it's a clean energy, green energy, which is serving millions of people there. The Africa Mobile Solar Unit is one of the success story because the mobile solar units can go from one place to another in order to supply power in a distributed green manner. Singapore Smart Green Buildings is one of the initiative, very, very excellent initiative in this small landmass called Singapore. And as you know that Singapore's growth in sustainable way is being highlighted everywhere. The Singapore's actually, the green building uses smart sensors to reduce energy uses up to 30%, which is actually quite a bit. That means that it's 1/3 energy is actually saved because of the green buildings. And there are sensors when people actually move out of their rooms or hall or chambers, the lights automatically switch off. And the corridor lights are also not on all the time. These actually, as you walk through, the lights get on, and as you go away, the lights behind you, they are switched off. So give you the light while you are walking and save the energy instantly. So these are some of the isolated efforts, but they are the blueprints for the scalable, sustainable, and societally inclusive models. Now, a lot of things to learn from these success stories. So especially the students, those who are sitting here, I would like to give a message that they must think green. They must read a lot about it, where people have actually put their actions into a sustainable way in a very successful manner. So the next slide actually talk about the power of interdisciplinary collaborations. Now, engineers plus ecologists plus data scientists together, scientist thinking approach and technology rooted in ethics. Now, when we talk about environment, friends, the ethics is extremely important. I mean, we should not think that this earth is only for our lives, nothing to before our life and nothing after our life. That's a very wrong approach and very unethical. So I would like to talk about two things. One is the interdisciplinary imperatives and other is the ethics. So sustainability is not a domain of engineers alone. I mean, if you leave everything to engineers or scientists, that they will manage everything. So science has certain limitations. Up to some extent, science can improve, but more things are improved because of our behavioral change. And that comes out of our dedication and ethics and our responsibility. So it is not alone for the engineers, and it is where engineers meet ecologists, where technology meets sociology and where innovation meets ethics. So we need collaborative framework in order to solve these problems. One is the environmental scientists to guide us, data scientists to measure impact, and urban planners to envision livable cities, and economists to make solutions viable. That means the optimal expenditure on development. And the government and industries to implement policies that foster long-term adoptions. So green engineering then is not just a technical, it is a deeply human efforts. So very human and sensitive way the development has to be planned by engineers. How many minutes do I have further? Anybody can tell me?
Sir,
Okay.
Sir, excuse me, sir.
How many more minutes do I have?
Sir, 5 minutes more.
5 minutes.
5.
Okay,
Yes.
I'll try to cover in 5 minutes.
Yes, sir. Thank you.
Though actually you should have given me 1.5 hours at least to talk.
Sorry, sir. Sorry.
Anyway, because there are so many things actually with the sustainable development and green engineering that 15-20 minutes talk, actually, I have to cut short many things, many ideas. Now, one very important factor is called engineering education. Now, how do we educate our generations, our young minds? It depends that their way of thinking should be in that way. So let us reflect on the education, the true foundation of sustainable change. We must restructure engineering curricula to embed sustainability principles, life cycle analysis, and environmental ethics. So project-based learning must replace the rote instructions which students solving real-world challenges. We have, sorry, I have to go backward. Previous slide, okay. So we have to actually add sustainability in curriculum, project-based learning, and encouraging global citizenship. So like project-based learning means we must replace rote instructions with the students solving real-world challenges, from water purification in rural villages to designing carbon-negative homes. And of course, a lot of tree plantation is needed in order to cover the surface of the earth with more green, and plants actually clean the environment, and which is good for the human health. We must also promote the idea of global citizenship and reminding young engineers that their innovation affect not just the shareholders, but future generations and ecosystems. There was a saying that one old man was sowing an apple tree. One passersby actually asked that, you are so old, the apples will come after 60 years. By that time, you will not be there. The old man told, well, gentlemen, I'm not planting this apple tree for myself. I'm planting this for the future, for my children and grandchildren and great-grandchildren, because they will be enjoying it. So the reason behind all this, this example is, the explanation is that for environment, you should do something which is not only restricted, or the benefit should not be really actually enjoyed by you, but it should be enjoyed by the future generation as well. We should leave this earth much more greener and better for future generation. Now, as you all know that the UN, United Nations, have 17 Sustainable Development Goals. In fact, all Sustainable Development Goals, these 17, are related to environment in some way or the other. But 12 of these are directly dependent on the green in an engineering or green technology. The SDG 6, that is the Sustainable Development Goal number 6, is called clean water. The Sustainable Development Goal 7 is a clean energy. SDG 9 is the industry and innovation. SDG 11 is sustainable cities. SDG 12 is responsible consumptions. And SDG 13 is climate action. I mean, these and some others are highly dependent on the future technology or a green technology. So what we have to really look into, we have to look into the policy gaps and financial constraints. There is a triple helix approach, which involves the public, private, and academic partnership. That is a triple helix, which actually is the model for the future, and the raising awareness and community trust. These are the barriers and pathway to move forward. The vision of tomorrow. Before I close, I would like to just show 2 more slides to you. And the first one is the policy support, and which is quite essential. And green innovation needs incentives, subsidies, regulation, and rewards sustainability. Industry collaboration is a key. Academia must partner with the corporations or corporates to scale green solution, and public awareness must be raised. So we need a lot of voluntary organizations, lot of youth brigade to go far-flung areas and make people aware about the climate and the environment. So this is very important. So the vision for the tomorrow or vision for the future, actually, it means that we must create cities that breathe, not just expand. When we say cities breathe, means see the quality of air over Delhi or NCR. Now, sometimes you can't even breathe properly because there is so much of smoke and so much of filthy, gases, and you can't breathe. The forms that regenerate. So you must actually need forms that nurture the land, not deplete it. I just spoke on the first sentence that by the time my introduction was actually read, there are about 30 football fields. Forest was actually cut down by contractors. Now that is in the world. So the rate of depletion of the forest is at the rate of 1 minute per football field or so. So we must actually keep the vision for the future, and we need a world where growth and nature coexist, not collide to each other. So these are the things. And one more thing, that the vision for tomorrow means replacing the paradigm of exploitation with one of the regeneration. Reuse, you know that several R's are there: reuse, recycle, and other R's. It means that a building is not just infrastructure, but building should provide you hope. As Singapore has done that smart green building, I think we must resort to that. And my final words before I close. In conclusion, dear friends, sustainable development is not an option. It is the only path forward. I mean, it's not that various choices are there that you choose to be following the sustainable development. There's no other alternative of sustainable development. So it is the only path forward if we have to move. Engineering tomorrow means taking action today with urgency, integrity, and vision. So no procrastination in this, no postponement of what we have to do today. Oh, it will be done tomorrow or day after tomorrow. No, that kind of concept is not there. in climate change and in sustainable green development. To every participants here, you are not just future engineers or change makers or change agent. You are future stewards of this planet. You are the protector of the future of this planet. To every academician, policymakers, and industry leaders, let us reimagine success not by what we extract from the earth, but by what we give back to the earth. Let us engineer systems that outlast us, not just in a function, but in the faith to the future. So let us not just build things, let us build a better world. So with these words, I would like to thank you all and for listening me. But let me tell you that this topic, which I spoke to you, has so much of length and breadth and depth that you keep on reading, planning, and then executing at the same time. I think a collective thinking is required, and I wish all the best to the future generations. My young minds are the future of the earth, future of the world, and we would like to see next coming, like Viksit Bharat's, the mission which is there by the Prime Minister of the Government of India. Let us be part of that and try to ensure that in a best way possible, in a sustainable way, let us keep India as a world leader by 2047. Thank you so much.
We deeply appreciate. Hello. We deeply appreciate the time and the effort you invested in preparing and delivering such a thoughtful, thought-provoking address, sir. Your insights into climate crisis, global resource pressures, sustainable growth model, and clean engineering, clean transport were particularly valuable. If I want to summarize, I can just say that the whole summary of his talk was basically Vasudhaiva Kutumbakam, meaning the world is one family. It's inherently linked to the sustainable development by emphasizing interconnectedness and sharing responsibility, promoting holistic development and well-being. Thank you very much, sir.
Thank you.
Now, I would like to introduce our second keynote speaker, Dr. Nilima Kumari. Dr. Nilima Kumari is a professor in the Department of Bioscience, Biotechnology, Banasthali Vidyapeeth, Rajasthan. She obtained her PhD Biotechnology in 2005 and has doctoral and postdoctoral visits in famous institutions in Germany and Finland. She has an impeccable track record in academics with a standing of around 26 years. She is currently working in plant biotechnology and has made significant contributions in plant stress biology, which have been globally acclaimed. She has also guided around 24 PhD students, many of whom are well placed in academics and industry. She has also been conferred with 2 Young Scientist Awards, 1 Female Woman Scientist Medal, and 1 Distinguished Scientist Award by reputed national scientific societies. Over to you, ma'am.
आशा तेरी मेल क्यों नहीं आ रही है इसमें? नहीं है। मैम एक्चुअली पेन ड्राइव का स्लॉट नहीं है, एक 2 में कैमरे लगे हुए हैं, वही ना
ट्रांसफर तो कर दिया
मैम। आई हैव मेल्ड योर पीपीटी टू दिस कंप्यूटर।
अच्छा ठीक है
यस मैम ऑन। आशा एक बार मैं मेल करते हैं व्हाटएवर। हाँ मेल बता यार, मेल दिख नहीं रहा। आस्था मेल कर दे एक बार वापस। एक मिनट रुक जा, मैंने लगाई थी पेन ड्राइव से। हाँ मैं कॉपी कर देता हूँ। यस मैम। और मैं देखना उधर से कौन सा पी रहा है। टच नहीं है। यस मैम, इसको प्रेजेंटर्स व्यू में ये लीजिए मैम।
Hello, I'm audible to everybody? Hello? Am I audible to everybody? Yes. Okay. So, good afternoon, all of you. First of all, I thank Professor Dr. Amit Jain, Vice Chancellor of the University, then Pro Vice Chancellor, Professor Aseri, Dean Research and Director, Professor Vinay Sharma, Director, Amity Institute of Biotechnology, Organizing Chair of the conference, Dr. Manju Kaushik, and Dr. Vijay Chaudhary for inviting me to deliver a lecture in this conference. So I shall speak on one of the abiotic stress biology topics, that is silicon mediated alleviation of fluoride toxicity in cereal crops, and will give some insights from wheat and oat cultivars. So if we talk of the stress in the plants, then there are so many sources which bring about the stress in the plants. So obviously, whenever a plant is exposed to some stress, there will be some changes in the plants. So the sources include mainly the anthropogenic sources, which includes both metals as well as non-metals in soil and water ecosystem, which includes like the activities like mining, metal processing, agricultural practices like the use of the fertilizers, and the harmful emissions from the industries. Now, these toxic metals as well as non-metals, whether they are essential for the plant or they are not essential for the plant, but if they are in excess, then they will bring about or they will adversely affect the metabolic activities of the plants. Now, plants cannot run away from this stress since they are in the soil, so they have to manage with it. So the only way is that to reduce that stress so that the plant does not lose its productivity, otherwise it will have an effect on the agriculture as well as the economy of the country also. In our lab, my students are working on different aspects, both in biotic as well as in abiotic stress biology. So we are working on heavy metal stress also. Then we have also worked on drought stress, then salt stress, and this heat stress also. So today I will focus on one particular stress, that is the stress which is caused by fluoride. So fluoride, this is an anion of fluorine, which is a highly electronegative and most reactive element. Now, since this is highly reactive, so this is phytotoxic to the plants. This has become an emerging contaminant. This fluoride is naturally found in the earth crust. So it is found in rocks, soils, and water, and it is present in very high concentration in all of these. Now, since the fluoride is one of the most reactive non-metal, this is highly reactive. So if this is highly reactive, then this will accumulate in soil as well as in water, and Through this, it enters the plant and then it enters the food chain. So it will also harm the animals. So this will have long-term environmental and health risk for humans as well. This fluoride is released into the environment through the natural sources, that is the volcanic emissions and the weathering of the rocks. And since now this fluoride, it becomes mobile, this will enter the soil, it will enter the groundwater. From both of these, it enters the crops, fruits, vegetables, which are consumed by the humans. So since the plants are sessile, so obviously they will be sensitive to fluoride like any other abiotic stress. And this fluoride, it cannot be detoxified by the plants. So they do not have any mechanism. So this is a risk to both plants as well as to the animals. Now, if we look at the scenario worldwide, then this fluoride contamination is a big problem for all of us. In the groundwater, it is a public health issue since it affects millions of the people worldwide. Though it is affecting most parts of the world, the top 10 countries which are affected by this fluoride problem includes India as well. In fact, India tops the list in this list of top 10 countries. According to the World Health Organization, they have recommended that the maximum fluoride concentration in the drinking water should be 1.5 milligram per liter. But the water which we are drinking has much more amounts of fluoride. So it is affecting everybody. You see? So in India, millions of people are exposed to this fluoride threat. Now this naturally occurring fluoride in the groundwater has been reported up to 50 milligram per liter. So you see, only 1.5 milligram per liter is permissible, and in the groundwater it is 50 milligram per liter. So the concentration is very, very high. So it will affect, indirectly it will affect all of us. Ultimately it will reach the food chain. So this is the scenario of the fluoride concentration in many countries across the world, and you can see that in India, the concentration is very, very high according to the World Health Organization. So this is a real problem. Now, in India, about 80% of the rural population and 50% of the urban population, they depend on this groundwater for the domestic needs. And if the level of the fluoride is high in groundwater, then it is a problem. And especially this is a problem in the semi-arid regions. So India is at high risk of fluoride contamination because of the climatic conditions. So according to this study, the higher concentration of fluoride has been reported in almost all these states. So more than 22 states and 200 districts are affected by fluoride adversely. And especially the Rajasthan, you see Rajasthan tops the list. So Rajasthan, Andhra Pradesh and Gujarat, they are worst affected states with the fluoride. So I've already discussed the sources of the fluoride, both the natural as well as the anthropogenic sources through which the fluoride reaches the groundwater. Now, when this fluoride reaches the groundwater, its uptake is taken by the plants through roots as well as through the stomata. And then it is accumulated primarily in the leaves. Now, whenever the plant is exposed to some stress, so it will exhibit some symptoms. So some of the symptoms may be visible symptoms, some may not be visible. The visible symptoms include, let us say, the fluorosis, necrosis, okay, yellowing of the leaves and of the dead tissue. So they can be observed, so they are visible, and the changes which take place at the molecular level, they are the invisible systems. So here also the fluoride toxicity causes the necrosis, fluorosis and mottling of leaves. The growth and yield of the plants is reduced, and there may be premature leaf fall. This fluoride is uptaken and accumulated in the plants through groundwater. So it is taken through epidermis, which reaches the cortex, followed by endodermis, then pericycle, and then it reaches the xylem, through which it is conducted upwards, and then it reaches the leaves. Obviously, when there is fluoride stress, the growth and productivity of the plants will be reduced. So various molecular, biochemical and physiological processes in the plants will be affected, which will lead to reduced growth and development of the plant. The crop yield will be decreased and the grain yields and quality will also be decreased. This fluoride generally accumulates in the aerial parts of the plant. So if it accumulates in the leaves, it will lead to reduction in the photosynthesis. Obviously, the photosynthetic pigments will also be reduced. The reactive oxygen species will be produced, which will cause the membrane damage. Finally, the crop yield will be affected. Now, in order to alleviate or mitigate this stress, the strategy which we have used is the application of the silicon, which will help in reducing the fluoride stress. So this mineral nutrition is very, very important to maintain the plant in healthy state and also to increase the resistance of the plant to any stress. Silicon is one of the major nutrients which is very helpful for the plants for its growth and productivity. Silicon is the second most abundant element in nature after oxygen. So obviously this is naturally present in all the plants. Now this silicon has a multifunctional role. So it increases the yield and growth of the plant. So that means if there is any phytotoxicity in the plant, this can be used as a very effective measure. So this is cost effective, inorganic and readily accessible. Readily accessible because it is present in very large amount. It is the second most abundant. Now there are two mechanisms by which it helps the plant in the stress resistance. One method is the physical or the mechanical defense. So silica deposits will occur, let us say on the cuticle, on the leaves. Okay, so that is how it will protect the plant. And the other is the biochemical and molecular changes, which will affect the metabolic change, which will affect the metabolic processes in the plants, like the photosynthesis, nitrogen metabolism, and many others. So this silicon strengthens the physical barrier of the plants because it deposits into the plant cell wall. So cell wall, that is a very important structure which protects the plant cell. It also helps to maintain the structure of the plant as well as the structural integrity is also maintained. So especially in the cereals, because their shoot length is quite high. So this helps in providing the lodging resistance. So that means the plant does not fall, especially the cereals like the wheat and oat, etc. And also it will provide the resistance to several diseases. This is a general mechanism to show how the silicon is absorbed by the plants. So silicon is taken through the exodermis. Then it reaches the cortex, followed by the endodermis. Then it goes to pericycle, followed by the root xylem. Then it reaches the panicle and deposits in the cell wall. So then it is known as phytolith. Now this silicon is available to the plants in the monomeric form only. So if we see this structure further, the epidermis, cortex and endodermis is sheet. These purple dots, they represent any toxic metal, for example, metal or non-metal. For example, let us say this is fluoride. So this is the path through which this fluoride will enter the plant roots. Now, what happens is this silicon helps in the suberization. So suberin will be deposited in the endodermis. Now, if the suberin is deposited in the endodermis, then it will form a protective layer so that the fluoride or any other harmful metal or non-metal does not enter the plants, or it is not translocated upwards. So thereby it is regulating the uptake of toxic metals and non-metals by forming this protective layer. So there are several methods through which the silicon can be given to the plants. There can be seed priming. So the seeds, they are coated with silicon and then these are sown. So when these seeds are sown, so they will grow better. This silicon can be applied foliarly, that is through the leaves. It can be sprayed onto the leaves of the plant, and through stomata it will enter the plant directly. And also this silicon can be given in the soil, and from the soil it will be uptaken through the process which I had already shown earlier. Now, so when the silicon will be taken, okay, so in nutshell we can say that it will reduce all the stress factors and will help in the growth and productivity of the plant. So here I have given the example of two studies only from the cereal plants. So in first study, the silicon was given in the soil. So this was given alone and in combination with chloride stress in the wheat plant, that is Triticum styra. Wheat is a very important plant globally, since we all require wheat for our nutritional needs every day. And since every one of us is eating this wheat, so this demand of wheat is directly proportional to the growth of the population. So if the population needs wheat more, that means we have to protect the wheat from this chloride stress. If we see the scenario in India, so among the wheat producing countries, India stands third in the world. And in India, wheat is the second main food crop after rice. So it is contributing to country's economy also. So that means if we are increasing the yield of the cereal crops by protecting them from fluoride stress, it is also contributing to the national economy, because we will not have to import it also. So obviously this study was conducted on wheat plants. So 5 varieties of wheat were taken and the study was conducted on it. The soil was first given fluoride stress. So different concentrations of fluoride were given initially to the plant, and then we selected two concentrations, that is 400 and 500 milligram per kilogram fluoride stress. Then these seeds were sown in this fluoride enriched soil. And after 1 week, the silicon was given to the soil. So it will be taken up by the seedlings. Two concentrations, again these were also screened, 200 and 300 milligram of silicon was given in the soil. The analysis of growth parameters, the chlorophyll pigment analysis, then the photosynthetic measurements, determination of the fluoride content, that is its accumulation, how much it is accumulated in the plant. Then the determination of the silicon content, malondialdehyde content, determination of reactive oxygen species, especially the hydrogen peroxide, the activity of the this antioxidative enzymes, that is catalase, superoxide dismutase, ascorbate peroxidase was monitored. Then the gene expression for cellulose synthase was observed, and the determination of suberin content was also carried out. Okay, so it's all related study. Now the effect of silicon on the growth parameters was observed under the fluoride stress in all these 5 cultivars, and it was seen when the fluoride stress, the different concentrations of fluoride was given, then it resulted in reduction in the growth of the plant at all doses, because all these concentrations, they are the higher concentrations of fluoride which is available in the soil. When silicon was added to this fluoride contaminated soil, the adverse or the harmful effects of the fluoride stress was alleviated. So it increased the growth parameters, thereby protecting the plants from the fluoride stress. So these are some exact values, okay, of that how much concentrations of fluoride were given and how much the growth, the increase in the growth was observed after the application of the silicon. So the effect of different concentrations of silicon was observed on the growth parameters, that is shoot length. We can take any example here. So for example, in the in all the varieties, in the control conditions, the growth was normal. When the plants were exposed to fluoride stress, it resulted in decrease in the shoot length. As the concentration increased, more reduction in shoot length was observed. When the silicon was given, then it helped the plant to alleviate that stress, And if the concentration of silicon was more, then it helped in better alleviation or mitigation of the stress as indicated by all these values. Similarly, the effect on the root length was observed. The shoot fresh weight was observed. The root fresh weight was also observed. All the growth parameters were there. The dry weight of both shoot and root was also observed. So in all these cases, it was observed that under fluoride stress, the growth parameters are reduced, and when silicon is given, then it helps the plant to overcome the fluoride stress, resulting in more growth parameters. The tolerance index of the wheat cultivars was also observed under the fluoride stress. And after this, two varieties were selected. One was fluoride tolerant and the other was fluoride sensitive. And then the further studies were conducted on these cultivars. So here RAJ 4120 was selected and RAJ 4238 was selected. So 438 was sensitive and 4120 was tolerant. This is just a diagram to show how the plants showed decrease in the growth parameters when they were exposed to fluoride stress. And when the silicon was given, different concentrations were given, then it helped the plant to alleviate their stress and regain these growth parameters again. Here also an example is shown that when the fluoride is given, it results in stunted growth. So obviously root, shoot, all these growth parameters are affected. But when the silicon was given, the plant regained the growth parameters. The next effect was observed on the photosynthesis. So photosynthesis is one of the most important processes which sustains the life on Earth because it results in the production of food both for plants as well as for the animals also. So here the effect on the photosynthetic pigments was observed. So when the plants were exposed to fluoride stress, there was decrease in chlorophyll A, chlorophyll B, total chlorophyll content and carotenoids content. And when the silicon was applied, then it resulted in enhanced concentrations of these chlorophyll and carotenoid pigments. So here we can see the percentages by how much the pigments were increased. This is the actual data which is here. Then further, the chlorophyll fluorescence parameters were used in order to determine the photosynthesis. So here the photosynthesis was measured in terms of the electron transport rate and this yield, that is photosynthetic efficiency of photosystem 2, which is represented by delta F by Fm prime sat here. So here also it was seen that when the plants were exposed to fluoride stress, then there was decrease in the chlorophyll fluorescence parameters, which is indicative of the photosynthesis. And when, so these are the graphs which show this electron transport rate and yield of the photosystem 2. And when the silicon was applied, then it resulted in enhanced electron transport rate, saturating photosynthetic active radiation, and also the photosynthetic efficiency of the plants was also increased. These are all these parameters which is shown over here. Then further, the accumulation of the fluoride in different plant parts was also considered. So if the fluoride is translocated more and it reaches the leaves, that means if it goes from the lower to the above ground parts, then it is harmful for the plant. So the accumulation of fluoride was checked in the plant when it was exposed to fluoride stress. After that, the silicon treatment was given, and when the silicon treatment was given, it was seen that there is less translocation of fluoride to the upper parts of the plant as compared to the underground parts, that is the roots. So the translocation is lower when the silicon is applied. After that, the accumulation of silicon was also observed in the wheat plants. So it was seen that the silicon also accumulates in the plants. The exact values again are shown here. And there was a little reduction in silicon accumulation in the plant. Then it was treated with fluoride. After that, the damaging effects of fluoride was seen in terms of the malon dihaldehyde content. So when the plant was exposed to fluoride stress, the malon dihaldehyde content is increased. So this is harmful for the plant. But when the plants were given the silicon treatment, then this malon dihaldehyde content was decreased, thereby protecting the plants. Then the effect on hydrogen peroxide was observed. So that is a reactive oxygen species were seen. The reactive oxygen species are very harmful for the plants. So when the plant was exposed to fluoride stress, then the reactive oxygen species were produced. So obviously the content of hydrogen peroxide will be higher. When these plants were treated with silicon, then the content of H2O2 reduced, thereby overcoming the stress. Further, the effect of this silicon was also observed on the activity of antioxidant enzymes like catalase and ascorbate peroxidase. So again, the silicon treatment showed that it is helping the plants to reduce the reactive oxygen species. Now, another aspect is that the effect of this fluoride and silicon treatment was observed on cellulose synthase gene. So this gene expression was observed by RT-PCR, and it was seen that under the fluoride stress, the gene expression is reduced. So if this gene expression is reduced, it will have direct effect on the cell wall of the plants. But when the silicon treatment was given, then the gene expression was enhanced. So what happens is that the cellulose synthase gene helps in the synthesis of the secondary cell wall. So if the secondary cell wall is stronger, then overall the plant cell will be stronger. Or we say that it will mitigate the effect of the fluoride stress. Then this effect was also observed on the suberin. So obviously, if there is a coating of suberin in the endodermis cells in the Casparian strip, then the plants will be able to overcome this fluoride stress, because now this layer of suberin will not allow the fluoride to go upwards in the plant. So the same was observed here. Suberin was seen here. So it was seen that suberin was observed in terms of the suberin monomers. This was monitored through gas chromatography mass spectrometry. So here all these fatty acids, hydroxy fatty acid, dicarboxylic acids, alcohols, all these are the monomers which make up the suberin. So that is why the content of all these suberin monomers was measured. So in any one of the graph, we can see that in the control parameters, there is a definite amount of each one of these monomers. When the plant is exposed to stress conditions, then less of suberin monomers are there. When the silicon is given, then again the concentration of suberin monomers is high. So that means it will lead to suberinization, which will help the plant. This is the content of all the suberin monomers. So the conclusion of the first study was that when the plants are exposed to fluoride stress, it results in reduced growth and development, and the structural integrity of the plants is affected, which is shown in terms of the reduced photosynthesis, increased fluoride accumulation, reduction in suberin deposition, and downregulation of cellulose synthase gene. But when the silicon is applied, all these harmful effects are overcome, and it results in increased growth and development of the plant and enhances the structural integrity of the cell wall. So this silicon, since it is not harmful for the plants at all, even if silicon is given in higher concentration, there is no harmful effect. So it can be recommended to the farmers. So silicon is an alternative to conventional chemical fertilizers. So this dose can be optimized, and then it can be recommended to the farmers, so that along with the conventional fertilizers, they can also add this silicon to the soil, so that it helps in the overall growth and development and productivity of the plants. Obviously, the chemical fertilizers are harmful, and the silicon is not harmful to the plants at all. So this is a safer alternative to the plants. So this is one strategy which we applied. This study was published in very high impact factor papers like Journal of Plant Growth Regulation, Journal of Soil Science and Plant Nutrition, Silicon, and Serial Research Communications. Now, in the second part of the study, the other aspect was used. So the first aspect was silicon was given in the soil. Now, the silicon is administered in another form, that is in the form of nanoparticles. So here we are using the technology part and giving it in a modernized way. So, and we are observing the same effect. So I will summarize it. I'm not going to so much of details. So this study was carried out in another cereal, that is in oats. So these days you see oat, people are consuming a lot of oats as an alternative to rice or wheat or other cereals. So they prefer it because it is high in vitamins, antioxidants, proteins, lipids, and especially the beta-glucan. The beta-glucan is there. This beta-glucan helps in regulating the cholesterol metabolism or the lipid metabolism. That is why people prefer it over the other cereals. So we say that it reduces the risk of degenerative diseases because of this reason. And it also provides the important nutrients for the human health. I hope everybody knows what is nanotechnology. So here the nanoparticles of the nano size, they are used. So these nanoparticles have we can say that positive effect on the plants, which was observed here. So these silicon was administered to the plants in the form of nanoparticles. So this can be used as nanofertilizer. So in our lab, we have synthesized different types of nanoparticles and have observed their effect on different types of abiotic stress. So here in this special case, we synthesized the silicon nanoparticles. These nanoparticles, they can be applied to the plants through leaves, through roots, seed brining, etc. Finally, they will result in increasing in the crop productivity. This nanotechnology in agriculture, this is now used very often. Now, this is a green technology because here the nanoparticles which have been synthesized, they have been synthesized by biological methods. So, this is green synthesis of the nanoparticles. So, they are not harmful to the plants or they are better than the chemical nanoparticles or the nanoparticles which have been synthesized chemically. So, these are safe and energy efficient. Also, these are not very expensive. It has been seen that these nanoparticles increase the enzyme activity in the soil. They have an effect on photosynthesis. They also affect the plant growth and development. They affect the nutrient uptake in the plants and also the yield of the plant. So here the biosynthesis and characterization of the nanoparticles was carried out and then their effect was observed. So here the nanoparticles were green synthesized from the leaves of Polyalthia longifolia, that is the Ashok plant. This is the process by which they are synthesized. Then these nanoparticles were characterized, that is whether they have been synthesized or not, through the highly sophisticated techniques, that is UV visible spectrophotometer, X-ray diffraction technology, zeta sizer, then FTIR, and this scanning electron microscope. Through UV visible spectrophotometry, the peak at 320 nanometers indicated that silicon nanoparticles have been formed. The zeta sizer and potential values showed that the particles which have been synthesized, these are stable nanoparticles. The X-ray diffraction technology shows the size of the nanoparticles, which was less than 100. So here it was 24 nanometers. So actually the nanoparticles have been synthesized. So we have to confirm it whether they have been synthesized or not. The shape of the nanoparticles was observed to be spherical. And this was observed through scanning electron microscope. The functional group action was carried out by Fourier transform infrared spectroscopy. Here also in this case, the soil was treated with different concentrations of fluoride. And then 2 concentrations were selected. These silicon nanoparticles were given through leaves. Earlier, we had given the silicon treatment through soil. Here, it was given through the leaf. So, this is foliar application of the nanoparticles. The screening of the oat cultivars was carried out in the same way. Out of 6 cultivars, 2 cultivars that is tolerant and resistant were selected for the fluoride tolerance. Again, the germination percentage, the growth parameters, they were observed. Again, under the fluoride concentrations, it will result in the overall decrease in the growth of the plants. And here it is shown that if the fluoride concentration is increased, then the growth of the plants is reduced. All of these, shoot length, root length, shoot fresh weight, dry weight, etc. So this is for all 6 varieties. The tolerance index was seen, and on the basis of this initial screening, 2 cultivars were selected. So the further study was carried out on the 2 cultivars. The effect of 2 concentrations of silicon nanoparticles was observed, and out of which it was observed, 1 concentration was finally selected, which was the best, that is 150 milligram per liter. So this concentration was selected from the study. When the plants were treated with, let us say here we have given 0, 50, 100 and 150. So that the best effect was observed on the the silicon nanoparticles, that is 150 milligram per liter. So that is why this concentration was chosen, and the studies were, or the parameters were seen. Again, here also the effect on the antioxidant enzyme activity was observed. So here also it was seen that the silica nanoparticles increase the activity of the antioxidative enzymes which protect the plant from reactive oxygen species. Then the effect on proline content, polyphenol content, that means the accumulation of osmolytes and secondary metabolites was also seen. So here also it was seen that the content of all these osmolytes and secondary metabolites was increased when the plants were treated with silicon nanoparticles. The effect on malondialdehyde content and H2O2 content was also observed. The accumulation of chloride was observed. So all the effects were same, like the previous effects. The difference was only the mode of administration of the silicon in the form of silicon nanoparticles. So the conclusion of this study was that when the abiotic stress in the form of fluoride is given to the plant, it will result in reduced growth parameters and the metabolic processes. And when the silicon nanoparticles were given, it results in alleviation of the stress. So this is the summary of this. So here in future, the focus on the transcriptomics and the proteomics analysis, or the molecular pathways by which the silicon is affecting the plants, it can be seen. And the same strategy can also be applied to different types of food crops under different types of abiotic stress. In fact, we also have carried out this study already using different plants and different types of stress. So from this second study to until now, 2 publications have already been published. One has recently been published last week only. So this was published in Journal of Soil Science and Plant Nutrition and Journal of Plant Nutrition. So finally, I conclude that the emerging strategies for the removal of the stress are very, very promising. So to alleviate the abiotic stress, so these treatments will boost the growth and productivity of the plant and also help the plant to build resistance to these stresses. So this molecular biology and this can be integrated with the agricultural inventions to develop the resistant crops for the future. A very big thanks to Professor Vinay Sharma. I am very fortunate to be his student, and I have been introduced into this research world. Under his expert and able guidance, so I'm always thankful to him. My very talented student, PhD students who carried out this work, so they also work very hard to carry out these different types of and this advanced type of work also. So Poonam, Anju, Gargi, Sonal, Tamanna, and Pragya. So they have worked in this area. Thanks to my institution, I have free also for all the facilities. To DST for providing the infrastructure facility and CSI also for providing the fellowship to my students. Thank you all. Any questions are there?
Any questions, any queries from your side?
Okay then, thank you.
एक मिनट कैमरा ऑन कर
फोटो मैंने इधर भेजी है ज्वाइन। हाँ वो तो ज्वाइन हो गए।
चल क्यों नहीं रहा है
इनसे
इसके बाद कितने आने वाले
एक मिनट।
यस मैम
I would like to pay my deepest gratitude to Professor Nilima Kumari for sharing your expertise on this critical topic. Your presentation not only highlighted the challenges posed by fluoride toxicity to plant health and agricultural productivity, but also showed promising ways of using silicon to address these issues through sustainable approaches. We are truly grateful to you, ma'am, for taking the time to share your valuable insights and inspiring us to consider how we can all contribute to a more sustainable future for agriculture. Now, I would like to welcome and introduce our third keynote speaker of the day. It is Dr. Nameer Khairullah Mohammed, Assistant Professor. Dr. Nameer Khairullah Mohammed serves as a Director of the Scientific Affairs Department at Tikrit University, Iraq. He is a faculty member and a senior lecturer in the Department of Food Science, College of Agriculture, where he focuses on advancing research and innovation in food technology. His research expertise is on oil extraction, microencapsulation, powder technology, food technology, emulsions, and nano-emulsions. Over to you, sir. Thank you. Hello?
Hello,
Yeah, you are
do you hear
audible.
me?
Yeah, you are audible. Hello. You are
All
audible.
right. Okay. So,
Hello, Dr. Naveed.
yep. One second, I just want to share the slides.
Yeah. It's a.
I don't know how will I be able to share my slides.
They are visible. Dr. Naveed, they are visible.
But I will not be able to move it anyway. All right. Okay, good evening. Honorable organizers, distinguished colleagues, esteemed faculty members, and participants. It's my great honor to join you today as a keynote speaker at the 5th International Convention on Green Environment, Technology, and Entrepreneurship through Innovation, organized by MIT University, Rajasthan. Although I'm addressing you virtually from Tikrit University in Iraq, I feel deeply connected to this global platform that brings together innovation, sustainability, and entrepreneurship. I'm Assistant Professor Dr. Namir Khairullah Mohammed, serving as a faculty member in the Faculty of Agriculture, Department of Food Science, also the Director of Scientific Affairs in Tikrit University. On a personal note, I hold a deep connection with India as my second home, as I completed my master degree in India in Schwartz University in Allahabad from 2010 to 2012 with all my colleagues, Indian friends. That academic experience shaped my career and strengthened the privilege and my passion for research. It is therefore a special privilege to return to the Indian academic community through this important convention. And special thanks to my colleague, Dr. Arpit Srivastava, for inviting me here. So I would like to start with my slides, and my keynote will be focused on the microcapsulation of natural oils, specifically the pomegranate seed oil, but I'm just facing issue how to present the slide. Is it clear there?
Amit, can you present, can you change the slide?
How to move it? How to move to the next slide?
Can you stop the presentation and start again?
Okay. Okay.
I
think now will be okay. I think. Okay. Okay. Perfect. So
yeah.
All right. So the title of the keynote will be the microcapsulation of pomegranate seed oil, advances, stability, functionality, and food application. Okay, so I just want to, sorry, I don't know how to hide the record, sorry. Is it clear there? Okay.
Yes, it's visible.
But it's not visible for me, only the whole. So,
can you stop presentation and start presenting again?
Yeah, I'll try to view. No. Sorry for this issue. Okay, now it will be okay, better. Okay. Okay. So I'll talk about the global challenge in food sustainability and nutrition. As we know, growing global demand for functional and sustainable food ingredients and nutritional losses and instability of bioactive compounds. For example, the polyunsaturated oils, specifically the fatty acids and antioxidants. Also,
slides are not visible.
oh, okay. So actually, I'm sharing the slides.
Yeah.
It's shared already. Okay. Share my slides.
Yeah, now they are visible.
Is it visible now?
Yeah, yes, it's visible.
All right, but when I make it a full screen, I will not be able to move to the next slide. That's why I exit. I don't know what is the issue with this. All right.
Yeah, these are changing.
All right. So I will not be able to make it a full screen, Doctor.
It's okay.
Anyway.
Okay.
All right. So I'll try to just maximize. Sorry. Yeah. So also local relevance, like here in my area in Iraq and region, underutilized agro-industrial byproducts, especially the seeds, the shells like rice bran, seeds of pomegranate fruit, and etc. It is a target for our research area. Innovation need like eco-friendly technologies to preserve and to deliver sensitive bioactive compounds. Why pomegranate seed oil? Actually, it is rich in bonic acid, which is considered as one of the most antioxidant fatty acid, which is only available in the pomegranate seed oil. Also, the tocopherols and sterols. In addition to the health effects as an anti-inflammatory, antioxidant, and anti-cancer. But it is one of like it is the highly unstable oxidation to the light and to the oxygen and heat. So the problem, it is a very rapid to oxidation and will cause rancidity, and of course will lead us to losing in the bioactive compounds content. Also, it has a limit direct use in foods, especially the oil, and nutraceutical. If I ask now anyone from the audience, have you tried the oil from the seed of pomegranate? I'm sure nobody will try it, or very few. That's why we focus in our research, especially my students, to utilize these types of byproducts and extract the oil from these sources. Also, it is an industry challenges like stability and deliver health benefits. So I move to the next slide. Why microencapsulation? To solve these issues and problems, we suggest microencapsulations as a technology, as a green technology and sustainable to protect the oil from these environment factors, like I mentioned before, the oxygen, the heat, and the light. So microcapsulation will protect oil against oxygen, light, and temperature. Also mask the strong flavor and aroma, especially for oils such as for fish oil or black seed oil. It has a very bitter taste or rancid taste. So microcapsulation, I mean encapsulation by wall material, will try to mask this maybe unpleasant flavor. Also, control release in the digestion. So we can control the release of these bioactive compounds in the intestine and etc. Also, extend the shelf life, which is actually our target to save and to protect the functionality of the bioactive compounds and the core material. So we have actually many techniques for encapsulation. The most probably used and most common techniques are spray drying, due to its common and availability in the industry. Also, the freeze drying, especially for the pharmaceutical sector. In addition to the conservation, like high encapsulation efficiency, one of the most benefits of this technique. In addition, also the nano emulsion and liposomes techniques due to the advanced and targeted delivery. So for these techniques, we need to use and utilize some types of wall material to coat the core material. So commonly used, it's the proteins and polysaccharides, or the combination of both of these. Proteins such as the whey or soy or gelatin. Also, the polysaccharides will be commonly used, the maltodextrin, gamma arabic, and starch. And the combination of these, of course, we will get a high microcapsulation efficiency. So one of the most common technique used for the encapsulation of oils, and specifically for the pomegranate seed oil, is the spray drying. Spray drying is the most industrial feasible method due to its high encapsulation efficiency. Usually we get more than 80%, which is considered as a very respected percentage for this technique, and produces spherical and stable microcapsules when we use SEM to visualize or to check the morphology of the particle, and the also for the emulsions used. In addition to the oxidative stability, microcapsulated oil, always we get a significant improve due to the using of a spray drying for encapsulation of oils. Also, the second technique, it's freeze drying and conservation. It is also has some advantage and disadvantage. Its advantages, we can get a high microcapsulation efficiency, reach up to 90% and more. But the disadvantage is quite the cost of the use and limited availability in the industrial sector. Also, we use the nano emulsions as an advanced system for encapsulation of oils, specifically for pomegranate seed oil. And the particle size for the nanoparticles will be in the range of less than 200 nanometer. And also, these techniques improve the bioaccessibility in digestion system and application, like we use it for beverage and dairy products. Also, it is worthy to mention that I have a patent for the using the nano emulsion as a beverage. Me and my teamwork, we produced a nano emulsion, and we applied in food products as a whitening powder for coffee and for beverage. We have 2 patents regarding this, and actually we use these simple techniques and equipment, and the result always guide us and lead us to reach to our target, as we can protect the oil against the environmental factors, especially the oxidative stability and release. Encapsulation maintains stability for the weeks, actually, compared to the unencapsulated oil, or we can call it as a free oil, the oil without encapsulation. So when I say a few weeks, it's reached up to 6 months in a different temperature. Actually, we have several studies. We use the room temperature and refrigerator temperature, and also accelerated temperature, which is reached to up to 65 temperature. And we got a very acceptable result, and we prolonged the shelf life for the products. Also, the control release in a stimulated digestion ensures more bioactives reach to the intestine, which is ensured the feasibility of this technique. Also enhance the bioavailability of the bonic acid, which is available in abundant amount in pomegranate seed oil. As I mentioned before, the food application for this microcapsulated oils, especially I selected pomegranate seed oil, we can apply it in different food products, such as bakery, like in enriched biscuits and breads, dairy, like fortified yogurt and cheese, and also nutraceuticals, capsules, functional powders, and also improve the sensory acceptance. All these are actually a brief for my research. I have almost 45 papers published in a very high impact journal like food chemistry, food powders, and these work with my students, my colleagues. Actually, during my 10 years of experience since 2015 till now, I consider microencapsulation is my first option to use it to protect oils against oxidation and for oxidative stability. The challenge for and scale up for this technique is high cost of all materials and equipment. So we currently actually I'm working with my colleagues to find actually alternative wall material, natural wall material with low cost to scale it up with industrial production. Also, the process optimization. This techniques requires lots of work to optimize all the factors affecting the final product, from the optimizing the temperature, the humidity, the percentage, and the formulation of the wall materials as a wall materials and core materials together. Also regulatory approved and consumer acceptance, because our target is to produce a new product and we apply it and we encourage the consumer to consume the oils in its new form, like powder. We can apply it for bakery, for dairy products, or even we can use it to we can go more deeply to produce nano emulsions and nano products to coat the food products. Currently, I'm working, one of my students also working on to protect the to coat the burger and meat products. So we can use it in different and we have a wide varieties for the food products for this technique. Future direction, encapsulation, consider one of the green methods. So it is also has a small deliver systems, targeted release, polarization of byproducts for eco-friendly wall materials. That's why I encourage all the researchers and postgraduate students to focus on this area and to be interested about this area, to find alternative wall materials, and also alternative of combination of wall materials, and also try these techniques as it is available, and the cost of its usage is reasonable. So at the end, pomegranate seed oil is a high bioactive, but it is unstable. That's why our target is to find a technique to protect this oil. So the technique suggested is microcapsulation due to its stability for the final product and control release for the product. Also, choosing the technique and materials depends on the application. That's why I recommend to optimize all the factors, and industry adoption depends on the cost, safety, and regulations. At the end, as I mentioned before, I really encourage my colleagues, the researcher, to find and to study more about the types of wall materials and try these new techniques to produce a new product, and to encourage the consumer to consume this types of oils that it's not commonly used, like the black seed, the pomegranate seed oil. So I would be happy to communicate and to discuss with attendance for any question or any suggestion.
Thank you, Nabil. And now the session is open for question. Any questions? Any questions from anyone? Thank you, Nabil, for accepting our invitations on such a.
It's my pleasure, and all the best for you, and best regards to the all attendants.
You showcase your study. It was a very nice study in encapsulation, and we have PG and UG students of the food technology, so definitely they will gain knowledge of the encapsulation techniques from you. Thank you very much.
Okay, thank you very much. Thanks a lot.
Any questions, anyone? तो करवा लेना पड़ेगा, एक बार ज्वाइन करवा लो बेटा, मैम को मैम का दे दो, मैम ने ज्वाइन करेगी नहीं, इनका हो गया।
Share your presentation.
Everyone, excuse me, all of you are participants, also part. Can you have class right now? Yes. Workshop participants. Workshop participants. Please raise your hands. Workshop participants, please raise your hands. Workshop. Good afternoon, ma'am. Good afternoon, ma'am. Am I audible, ma'am?
Yeah. Good afternoon. Good afternoon.
Good afternoon, ma'am. Am I audible?
Yes. Am I audible?
Yes, ma'am. Yes, ma'am. You're audible. Ma'am, we are just putting up the presentation. So we now have 2 all candidates and the others have left already. They will be, one of them, they were not able to join today. So we are asking them to put up the presentation. So just join in 2 minutes, they will. Okay, ma'am?
Okay, sure.
Okay, ma'am. Come back.
मैम आपको अगर एक बार पीपीटी चेक करनी है तो आप चेक नहीं वो बस साइड के लिए अभी कराना है मैम ने तो ज्वाइन नहीं किया
आपका पीपीटी तो हो गया।
एक बार सब आ जाए उसको याद करने की हाँ अभी कर लो
I would like to call.
Now, I would like to call Dr. Arvind Srivastava, sir, for introducing our session chair, Professor Ekta Meghnani, ma'am. Sir.
Hello, good afternoon, ma'am. It's my pleasure to welcome you and to introduce you, Professor. Hello. We welcome you, ma'am. It's my pleasure to introduce you. Professor Dr. Ekta Meghnani is a professor and head Department of Biotechnology at JECRC University, Jaipur. She has been working in the field of Indian medicinal plants and their biopotential for 26 years. She worked in National Institute of Ayurveda, Jaipur for API formulations of Indian system of medicines and standardized 13 single and 9 compound formulation of ISM, that is Indian System of Medicines drugs, under Ayurvedic Pharmacopoeial Committee. Project sanctioned by Ministry of Health and Family Welfare. She has published more than 95 papers in national and international journals of repute, 15 projects sanctioned to her from various national funding government agency, and has presented various papers in conferences and seminars. She was also credited with the Center with Potential for Excellence in Biotechnology by State DST in the year 2009 to 2012. In 2012, she was awarded with country's most prestigious fellowship, Women Scientist Award. Further, she was also sanctioned with Women Technology Park by DST, New Delhi C Division and Government of India. She was also backed with DST DAT 2019 collaborative project with Dr. Draeger, Leibniz University, Hanover, Germany. Also worked on a joint collaborative project impact assessment of gender mainstreaming projects of Government of India in the year 2019 to 2021. Combination and interaction with women in science. She visited Leibniz University, Hanover, Germany in 2022 under an international project sponsored by Institute of Organic Chemistry, Leibniz University, Hanover, Germany by Pro-President Fellowship of Leibniz University. She did her postdoc fellowship from Leibniz University, Hanover, Germany 2023. She has published 15 books of various chapters with national and international review publisher. She is a fellow of Royal Society of Biology UK, Indian Botanical Society, Lenin Society of London, and Mendelian Society of India. She is backed with SN Dixit Gold Medal Award. So we welcome you, ma'am, on the behalf of Amity University, and we are very thankful that you have joined as a session chair in this session, and we will start with the session, ma'am. There is presentation. So now I would request the participants to come here and share your presentation.
You can speak from this also if you have any problem. इसमें echo ज़्यादा है. मैम, इसमें echo ज़्यादा आ रहा है. इसको पकड़ के
ये
आप
लिंक से जा रहा है कि नहीं जा रहा प्रेजेंट प्रेजेंट मैम को दिखनी चाहिए ना प्रेजेंट करके
यहाँ से किसी ने शेयर ही नहीं किया था। ये आपका कौन सा है? ये होगा
एक बार कंफर्म करिए क्योंकि मैम को दिख रहा है कि नहीं
मैम इज द
Hello, ma'am. Is the PPT visible to you?
ठीक है, yes, yes, I am able to see them.
Okay, thank you very much. Okay, so Tamanna Sharma from Vanasali Vidyapeeth, Department of Bioscience and Biotechnology will present her.
You can start.
So, good afternoon, everyone. Myself, Tamanna Sharma from Department of Bioscience and Biotechnology, Banastali Vidyapeeth. Today, I will be presenting my work on microwave stimulated germination and biochemical augmentation in capsicum seedlings. So, firstly, we start with some intro, that is, what is electromagnetic radiation. These electromagnetic radiation energy that is produced by the oscillation of electric and magnetic field. These both fields travel perpendicular to each other. Broadly, we classify electromagnetic radiations into two types, that is ionizing and non-ionizing radiation. We are using mainly non-ionizing radiations for in our study, mainly microwave radiations. Microwave radiations fall between 300 megahertz to 300 gigahertz and is further divided into various subbands on the basis of wavelength. So we are basically working with X band of microwave radiations, which ranges from 9 to 12 of gigahertz. Historically, first James Maxwell predicted the existence of microwaves. Then Heinrich proved the existence of microwaves experimentally. Then comes J.C. Bose, who pioneered the use of microwave radiations, various applications of microwave radiations. Then Percy Spencer is the first who who discovered the microwave oven. Then these microwave sources of microwave radiation, that is natural and artificial sources. So in agriculture, microwave radiation application is depend on various factors like power density, duration, and one of the main factor is specific absorption rate, that is SAR. We can define SAR. SAR is the measurement of how much of microwave radiation energy is absorbed by the biological tissue. So
Ma'am,
there are various applications.
Tamanna, your PPTs are not moving actually. It is just showing the first PPT only. Hello, am I audible?
Yes, ma'am.
Tamanna, your PPTs were not moving actually.
Ma'am, we are checking.
एक बार stop करें. Now can you see me?
Now can you see that?
Yes, now moving. Initially, they were not moving actually. Now I can see. It's okay.
So we used capsicum and a plant.
Yes, you can start.
But sir, वहाँ नहीं हो रहा है अब.
नहीं, अब विजिबल हो रहा है, पहले नहीं हो रहा था, अब दिख रहा है बेटा, अब दिख रहा है. Now start presenting. Speak.
Yes, sir.
Yeah, microwave. I'm saying, is it visible?
Yeah, up the crack.
Is it visible?
Yeah.
Okay, thanks.
So we have used capsicum and plant for our study because capsicum is highly rich in various vitamins, antioxidants. It is the highest capsicum has highest level of antioxidant. Then India is the fifth country in which capsicum fifth country in capsicum and use. So these are the benefits of capsicum. Then beta-1,3 glucan. It is primary enzyme which is involved in the germination of seeds. So these are the objectives of my study. Then methods. We have capsicum. 4 varieties of capsicum were introduced with microwave radiation. Through the setup of this glycerol-based microwave setup, there is artificial Faraday chamber in which the seeds were placed, and then the microwave radiations were introduced. Then these are the effects of microwave radiations. We can see that up to a certain level, microwave radiation can enhance the growth of capsicum plants, but its overexposure can further reduce the germination. We can see that up to 8 hours, the germination and biochemical morphological parameters increasing, but after that, the growth is declining. Then then the germination these are the germination parameters, germination percentage, rate and index. These are also increasing up to a certain level of micro exposure. After that, these are also declining. Then this is the graph of specific absorption rate, which is showing the absorption of non-thermal range of microwave radiation. Then this is the beta-1,3 glucanase, activity of beta-1,3 glucanase. Beta-1,3 glucanase mainly helps in the breakdown of endosperm. So endosperm cell wall so that a radical can emerge from the seeds and germination can start. So microwave radiation increasing the activity of beta-1,3 glucanase, but again, its overexposure can reduce the activity of this enzyme also. This is the FTI analysis of two varieties of capsicum, showing the changes in various cell wall molecules like proteins, lipids, carbohydrates, showing that there is change in the cell wall molecules due to the microwave radiation, which is further enhancing the germination of seeds. We can conclude that controlled level of microwave radiation can enhance the germination and other biochemical parameters, but up to a certain level, after that level, microwave radiation can be harmful to the plants. So that we can conclude that an optimal range of microwave radiation can be used to enhance the germination of plants. Then lastly, I would like to show my sincere gratitude to Professor Nilima Kumari for guidance and encouragement. I would also like to thank University Grant Commission, that is UGC, for providing me financial support. And lastly, I would also like to thank Professor Veena Sharma for his proper guidance throughout my research work. Thank you. Thank you.
Nilima, that was a very good work. Just I want to know that what you offer to the future generation, that whether they will use the microwave or not, or if use in what conditions and what limitations they will going to use.
Yes, ma'am. I can say that they can use microwave radiation, but there is a certain level that they can use. But after that level, microwave radiation is also harmful. So we can say that at a certain level, they can use microwave radiations for the plant growth of other purposes. But after that, microwave radiation is also harmful.
And my second question is, out of two varieties, which variety you find suitable or best, more giving the activity against this microwave processes, like in which the enzymes are working more efficiently?
Actually, there is not two, there is 4 varieties.
out of which I have found two varieties that are very suitable, that is Pusa capsicum and California wonder. The Pusa capsicum is red in color, so its enzymatic activity is very high. So I found it very suitable for my study. And then again, California wonder is yellow in color, which has high level of biochemicals or enzyme activity greater than green. So I found it also found it very suitable for my study. So these two varieties are selected.
Thank you, Tamanna. This was
Thank you.
good.
Thank you, ma'am. Thank you. Thank you. Next person will be joining soon, ma'am.
email सर ईमेल खोली किसने की क्रोम में ना सर मेरा प्रवीण सिंह तो डाउनलोड ये पुरानी नोटिस इसको बंद कर देंगे इनके बाद ईमेल का तो शेयर हो गया तुमने आ रहा है अगले को तो रही है
Excuse me, ma'am. Can you see the presentation right now?
No,
Of Praveen Singh.
no, no, ma'am.
Okay, okay. Then I'm asking Praveen to present it, ma'am.
जूम पे बंद करना पड़ेगा ना पुराना
तो पहले वाला
मैं कर लेता हूँ अब मैम को दिखाई दे रहा है
Yeah, now I am able to see, but you just enable editing at the top so that they can scroll that.
नो करके देख लो
ये ऊपर जो enable editing लिखा है ना, इसको या तो close कर दो या enable कर दो, तो ये आगे move करेगा, नहीं तो इसकी भी PPT move नहीं करेगी.
यही तो वहाँ देखो
Now start the presentation.
वही बेटी
हाँ ये आप सब यहाँ से शेयर करता हूँ ये चालू करता शेयर करो पर एक ये बाकी विंडोज क्लोज करके देख लो शायद एक वो शेयर हो जाए उसमें
क्या चीज
बाकी शेयर बंद कर दो किसी का तो आपकी वाली बस रख लो आप शेयर स्टॉप शेयरिंग
मैम इधर पीपीटी विजिबल
Yeah, PPT is visible. They can do from right side. Click करते जाएंगे तो next होती जाएगी. ठीक है.
Okay. So, good evening, everyone. My topic is about sulfur-lipid production and application in energy industry. So, first of all, we should know what is how sulfur-lipid helps in energy industry. It is used for enhanced oil recovery process where while the oil extraction from the reservoirs, it increases the capacity of extraction about 60%. From 30 to 40%, it increases to 60%. Okay. And what are the major challenges to use it? The major challenges are to use it that comparatively it extracts lesser than chemicals affected, but it is overall environment friendly and sustainable. Now I'll come to the part where how it is produced and how it is used. Okay, so the project scope and objective. The research was conducted where the sustainable production was done and application of surfactant was done, which was produced through Candida bombicola microorganism yeast, and the source where it was produced was waste frying oil. And my study aims towards the efficiency of biological agents compared towards the synthetic alternatives, where I used PAM polyacrylamide for the for more enhanced oil recovery, and CO2 was inculcated for extra enhanced oil recovery, and it helps to provide like a great environment impact as saving the environment from global warming, as CO2 is used in oil reservoirs. Now, what is my research gap and aim? A gap is like the synthetic surfactant, as I told before. It is quite environment. It causes environmental damage, but the surfactant which I produced or I used was environment friendly and was used in a eco-friendly manner for enhanced oil recovery, and it is a totally game changer. Like we can say that it will be used against or at the place of chemical surfactants for enhanced oil recovery, which will save the microbiota of underground landfills and mines. This is how it was produced. Firstly, the preparation of seed media was done. The seed media was observed that the desired microorganism is produced or not, which is Candida bombicola. After that production, the production media was produced and the sulfolipid was extracted from the Candida bombicola species after 120-hour cycle. This is the characterization of my surfactant, where you can see the aliphatic carbons and glycolipid and sulfurose head and fatty acid tail, where it denotes what type of carbon sources are present in this and what type of alkaline and aromatic carbons are present in my surfactant. This is the final and most important part of this PPT, where I will show the enhanced oil recovery, how it is used. First of all, 100 SL means 100 ppm sulfolipid was used for enhanced oil recovery, where you can see 6.60% only the recovery was done, but at 250 the recovery rate was the highest. So that was my highest enhanced oil recovery part from my surfactant. Then after that process, the surfactant was inculcated with the CO2 gas source and polyacrylamide source, and after the CO2 source was provided, the enhanced oil recovery increased by 13% more. And at the final graph, as you can see, the most down one, where I can show that where CO2 and PAM both was used, shows the highest recovery rate of oil extraction, which is represented by blue line. And this was my whole work till now, which I represented for enhanced oil recovery using the biosurfactant sulfolipid. And the conclusion overall is it is green, sustainable, environment friendly, it is cheap, and it does not create any harm to microbiota as we are moving towards the sustainable development. And I would thank AI Agri Department, MIT Institute, and the experiment which were conducted in RGIPT, Rajiv Gandhi Petroleum Institute of Technology, and my colleagues, my collaborators, and most important, my guide and my friends. Thank you. Ma'am.
Yeah, Praveen, it is a very good and precise presentation.
Yes.
Good. My just one question is that, can you tell me the difference between the biosurfactant and biosolvents?
Yes, ma'am. Excuse me.
Can you tell me the difference between the biosurfactants and biosorbents?
Yes, ma'am. Biosurfactant and biosolvent are quite two different things. Means biosurfactant is basically used in in my I'm telling according to my experiment. This can only be used in enhanced oil recovery process, but biosolvents are can be used in other we can use it in soaps, we can use it in detergents, and which won't cause any harm to environment and to the water bodies present on earth.
What are the steps that are involved in isolation of lipids? Can you elaborate a little?
Yes, ma'am. Means you want to know the extraction part, right? Ma'am?
Yes.
Okay, ma'am, this is the basic extraction part. First of all, I use the Candida bombicola species which was used in seed media for the growth. Okay, and after that, I observed it that the species, I confirmed it that the species is present or not, and after that, shake flask method is used for the production media. When the production media is digested by the yeast, the surfactant and the media separates in a broth, and after the centrifugation process, we extract the sulfur and then we test out like OD, pH, and oil spread test. Oil spread test is the main test where we can check that, as you can see in the PPT, the oil is spreading in a circular manner. So we can check over there that the oil is basically creating a missile to form can be used in an oil reservoir part or not.
See, this oil can be of many types. How you are identifying that this is the sporolipid only?
Ma'am, when according to this, ma'am, these are the studies, previous studies also. After that, I also performed these FTIR and NMR. Then I confirmed that these are sulfurolipid according to the sulfurose head and fatty acid tails.
So you think it's a very good alternative. What do you think about the contamination in the initial time when you are cultivating that microorganism?
Cultivation time, like I took it for 0 hours to 120 hours. Like in every 24 hours, the production media was tested, and when means after the OD, pH, and everything was tested, the oil spreading test was done lastly. If the last experiment means oil spread test was successful, then the NMR and FTIR was done.
My just one suggestion in that you also screen about the toxicity test before using anything. If we are doing the toxicity screening, that will be helpful to give you more eco-friendly results, right? If you are
Sure.
saying this is the sustainable, just go for the toxicity screenings also.
Sure.
Otherwise, your presentation is good. Very good. Thank you.
Thank you so much. Thank you so much.
Thank you very much, ma'am. And if anybody want to ask any question, we can ask. Hello. One more candidate will present her.
Okay.
Poster presentation. Is the poster visible to you?
No, because previous PPT is also already there.
Okay. Just wait a second now. Now is it visible now?
Yes, now it is visible.
Okay. So Richa Omar from Vanasthali will present now.
Good afternoon, all of you. I am Richa Omar from ICGETEI. Today I am representing my work on physiological and molecular analysis in penicillin glucose treated with green synthesized ZNO nanoparticle. In today's scenario, we observe that conventional fertilizers are effective but have some environmental issues. To combat these issues, I have synthesized ZNO nanoparticles by using Azaretica indica, in which we firstly synthesize the ZNO nanoparticles, then characterized by using FTIR. In FTIR, we observe that peak at 400 centimeter inverse, which continue the formation of nanoparticles. After that, ELS was done to check the nanoparticles showing the size 76.3 nanometer, and for external physiology checked by using SAM analysis. And after later on we check the ZNO nanoparticle effect on penicillin glucose at different concentration. Firstly, we check at physiological level. In root and shoot length, we observe the increment of graph at 100 to 150 mg concentrations in shoot or root. At biochemical level, we see the chlorophyll content also increase at 100 to 150 mg concentration, but DBPH activity also increased at this concentration and decreased at after 150 concentration due to the scavenging activity. And at molecular level, we check the transcription factor genes such as ERF2 and ERF3 genes. In ERF2 and 3 genes, we see the upregulation of these genes because of the zinc was accumulated at this concentration and transport to the root to shoot for providing the growth promotion of the penicillin glucose. After then we conclude our result. To show the increment of root and shoot length at this concentration, and finally perfectly synthesize the ZNO nanoparticles and see the result at 100 to 150 mg concentrations are good for growth promotion of permalate, and see the 200 concentrations are phytotoxic and show the cell damage in the penicillin glucose. Finally, I acknowledge my guide, Dr. Jyoti Mathur, and head of the Department of Banasthali, and also thank Amity University for providing me stage to represent my work. Thank you.
Yeah, Richa, it is a good presentation. You have done a good job. My simple question, can you elaborate or give the full form of DPPH?
Diphenyl picryl hydrazine.
What is it used for?
Ma'am, it is antioxidant. It show the firstly in stress condition we see the free radicals was create, and then DPPH neutralizes the free radicals due to 200 mg per kg concentrations was show the less in graph. At 150 concentration, free radicals was less created. इसलिए DPPH
at what nanometer we are going to read the DPPH readings?
517 nanometer.
Okay. So my one simple question to you, that apart from your experiments, which is what you are showing in the figure, which one is the control and which one is the blank? ये आपने लगाए हैं ना हाइट्स रूट शूट की हाइट लगाई, इसमें कंट्रोल कौन सा है और ब्लैंक कौन सा है?
मैम फर्स्ट वन इज कंट्रोल, जिसमें हमने कोई भी नैनो पार्टिकल नहीं डाला है. सॉइल में।
ठीक है, और ब्लैंक कौन सा वाला है?
मैम कंट्रोल ही हमारा ब्लैंक है जिसमें हमने सॉइल में कोई भी नल
नहीं, एक नेगेटिव कंट्रोल एक पॉजिटिव कंट्रोल भी रखते हैं ना।
मैम इसमें तो हमने के लिए पॉजिटिव नेगेटिव कंट्रोल किया।
तो अगर आप देखोगे फर्स्ट वाला और लास्ट वाला तो सेम ही दिख रहा है, तो कैन यू एक्सप्लेन दिस?
मैम फर्स्ट वाले में हमने नैनो पार्टिकल प्रोवाइड नहीं किया है और हमने लास्ट वाले में 200 mg पर kg की कॉन्सेंट्रेशन दी है, जिसमें हम ये देख रहे हैं कि नैनो पार्टिकल का इंक्रीमेंट की वजह से भी हमारे को सही ग्रोथ नहीं मिल रही है प्लांट।
That means you want to say if the correct concentration is not there, there can be a decline in the growth also.
Yes, ma'am.
So that means again it is causing some kind of toxicity.
Yes,
आप
ma'am.
इसका टॉक्सिसिटी स्क्रीन क्या है? IC50 जो अपन निकालते हैं वो कहीं निकाला है या LC50?
No, ma'am.
Okay. Good presentation. Congratulations. Thank you.
Any question from audience? Okay, thank you, ma'am. Thank you very much.
Thank you so much, sir. Thank you for giving me this opportunity. Thank you, Manju Kaushik ma'am also. Convey my regards to her. Thank you, sir. Thank you. Bye-bye.
Thank you, ma'am, for joining us today, and we will be sharing the evaluation sheet with you on mail, ma'am. So you can put the marks and get sent to us if possible, ma'am.
Sure. Thank you. Thank you.
Thank
sir.
you.
My pleasure.
Thank you.
So, all the best to all of you. All the students were good. Thank you.
Thank you, ma'am. Thank you. हाँ, फोटो इसको बंद कर रहे थे करके वीडियो फोन वो किया हुआ है सर। बंद कर, हाँ बंद कर लो और मैम को फोन कर लेना। मेरा फोन चाहिए। रेडी होकर के फिर करो। Thank you all, everyone. So thank you for joining. I hope you have the signatures and all, and thank you so much for your presence. Ma'am will be sending us the evaluation sheet and then sharing this on Wednesday. So, right now, and you're all registered for workshop, right? So I hope you had tea, which we can. Yeah, lately they are समय लोगों ने किया है ये मैं have it checked right now and tomorrow again either attending
Hello, there is an announcement. Cultural event is there from 5 to 6. If anybody want to join, he or she can join in auditorium.
प्रोजेक्ट किसने निकालना था?
तो लैपटॉप तो देंगे ना,
देंगे थोड़ी, वो लेके जाएंगे जितन से
लगा के रहने दो। ये बोला था वापस करने को, तो
कहाँ करना था?